Guys, let's solve this problem. The name of the problem is Ultima cifra nenula in our Replit team. So what we do is we read any numeric value from the keyboard. For example, we read 13. So first we must find the factorial of number 13, which is this number, and then when going from right to the left, I must find the last digit which is not equal to 0, which is 8 in our case. So I print out 8. So I will have this variable, and from the keyboard, for example, I will read number 10. So the value of my variable n will be 10. So the factorial of the 10 is 3,628,800. So when going from left to the right, when going from the right to the left, the last digit which is not 0 is 8 when going from the right to the left. So I must print 8. So how do I do it? So starting from the right, I must find the last digit. So if the last digit is not 0, I will print it. But if it is 0, I must remove this digit so that the last digit would be this digit. So how do I do it? First, I have this big number, so the last digit will be this number modulus 10. And then if it is 0, I will divide the number by 10. When I divide this number by 10, actually, I get this number. And again, I will find the last digit, which is this number, modulus 10, and again, it will give me 0. Since it's 0, I don't need it. Again, I will divide this number by 10, and eventually I'll get this number. Then the last digit again will be this number, modulus 10, and this time it will give me 8. I will print out 8 and I will break the loop. So to solve this problem, I will declare a variable n. And then I will read from the keyboard my variable n. And first I have to find the factorial of it. In my previous videos I showed how to find the factorials, so in this video I will not go in details how to find the factorials. So let's declare a variable for factorial, and at the beginning its initial value will be 1. And then to find the factorial of number n, I will create a loop which will start the counter I at 1, and it will continue until n. And every time in the loop I will increase the value of I by 1, and I'll say that the factorial is equal to factorial multiplied by I. So when I got the factorial, you see that I have to find the last digit, and if I cannot find the last digit, I will remove the last digit, and I will continue like this until I find the digit which is not 0. So every time I will divide this by 10. And as you see, this is getting smaller and smaller by 10 times. So I will create a loop which will divide this number by 10 until it gets, let's say, to 0. That's why I create another loop and I say while factorial is bigger than 0, I must find the last digit. So let's declare a variable for the last digit. So the last digit will be the factorial modulus 10. And if the last digit is not 0, or we could do this way, if last digit is bigger than 0, like both of them are okay. If last digit is not 0, then I'll print the last digit, and then I will break the loop. So you see that the loop will break only if this if statement is true. And inside the loop, after finding the last digit and checking if it's 0, I must divide the factorial by 10. So if the loop is not broken, it means we are going on. That's why I divide it by 10. So let's run the program. So if the number is 5, the factorial of 5 will be 120. So the last digit before 0 will be 2. What if we enter number 13. You see that it gives me the wrong answer because actually the factorial of 13 is so big that it does not fit inside of the integer data type. That's why there is a special data type for integer values, for long integer values, which we call long. So the long data type is for using numeric values which don't have a decimal place, but which are really long. That's why I will use long instead of int. Now again, run the program. For 5 it must give me 2, and for 13 it must give me 8. That's it.